Hi guys, and welcome to the last tutorial in this first module of our series Blender for Production, in which we talk now about the compositor. My name is Helge from pixeltrain. First, I want to thank you all for the positive feedback and all the new subscribers, the nice comments you left me on YouTube, and also the new patrons which I have now. Thanks a lot guys for your support. I will keep this series Blender for Production up, and I also want to add more tutorials in the future. But now we want to close the chapter The Compositor first, and in the last tutorials I talked about how this compositor inside of Blender works, how you do render layers and so on. And we also talked about how to make these passes here on every of these render or view layers. Now in this tutorial I want to talk about comping now these data passes, or use these data passes like the Z pass or the UV pass inside of the compositor, and also how to combine the light passes. So I give you the recipe how to comp everything back and how you can manipulate them. So I hope you enjoy this lesson here, and if you have questions please comment below, and if you like it, subscribe. So let's get started. You see I've restarted my computer, Blender is restarted, and if you now go to the compositor, you see I have no image at all at this moment. And the big advantage I've talked a lot about in this series is that I can start compositing my scene here, which I work here, and maybe I've linked in from another artist, and I can work here in lower resolutions, qualities, and so on. And so we want to use that now. So let's go here to the render settings. And what I do here, instead of rendering with 256 samples, let's go down and say 64 samples. Also what we can do is we go here now to the output properties, and here under resolution you find a percentage, and we say, okay, I want to render only in 50%. So it's much faster now. And then if you have made your composite, then you can go up to final quality, final dimensions, and everything will then work, for example, for a whole animation. That's the big advantage of this integrated workflow. Now we can render every of these render layers here by this little button, but because I want to have everything here, what I do is I make sure that the composite node is connected to one of these render layers, otherwise it will not work. And then we go here to render and render the image. And now you see the new image viewer pops up somewhere here in the UI. This depends on your preference, how you set it up. I said keep the UI, and then I switch back here to the compositor. And now you see all these three render layers are now filled. And what we can do, only for convenience sake, we can split this window here again. And we say here we want to see the viewer, and here we want to see the render result. That means if you now re-render, I do it only to demonstrate that to you. You now see that now Blender picks this render result viewer here, and you don't lose here your site and your settings for this compositor view. And the reason why I don't get this pop-up, we talked about that in one of the last tutorials, is if you go here in the preferences, so edit preferences into interface, here are the temporary windows. And here you can set that you always render in an image editor. And so Blender searches for an image editor, and then it puts its rendering into the image editor, which is tagged with render result. That was the reason here. Okay, now let's get started. The first thing I want to do now with you is I want to look into the so-named light passes. What are light passes? If you activated here passes, you get here these output nodes, and the same is if you load in a multi-channel EXR, you get the output nodes here. And what you can now do is we can first analyze them. So Control Shift, click here for example to AO, and what you now see here in the viewer is that this is the ambient occlusion pass which I rendered out for these moving objects. Great. And what I now do is I want to look into these diffuse passes here. You see, if we go into the passes here, under the light passes, you see every of these passes has three components: a direct component for diffuse, an indirect, and a color. And every render engine, not only in Blender but everywhere, has a recipe how a so-named beauty pass is composed. So beauty pass is the final image, the final result which you get here if you go to image. You see it's really noisy and it's low quality because of our settings, but this is the zone in Beauty Pass. And to build this Beauty Pass, the renderer has more than one step. And what we do here with the multipasses or AOVs or render elements, however they are named in your render engine, they have a recipe how you have to combine them. And in cycles, there is a special recipe. And this is the recipe we now want to talk about. So diffuse is the diffuse reflection of our object. But if you now look into, for example, diffuse direct, you will see, okay, we don't see any colors of the objects themselves. You see here how the objects look. They have these stripes here, but there are no stripes at all. What you see here in Diffuse Direct is only the contribution of the light sources in my scene. So the blue light from the top and the warmish light from the side. And so this Diffuse Direct, the same like Diffuse Indirect, are only shading informations from light. Direct means directly from the light sources, and the indirect part is the reflections of the light. So another renderer, we talk at this point here from GI, from global illumination. So this is the indirect reflections which are going on between, for example, the floor and these objects, or also between these surfaces here. But no information how the objects themselves are colored. So these two are only shading informations. The third one, the diffuse color now, this is the diffuse color of the objects themselves. Here you see our stripes. So what we now have to do is we have to comp this. And for comping, we normally use one of two nodes. And you remember in the first tutorial, we make quick favorites for them. So if you press the Q key on your keyboard, quick favorites, you see these two nodes. We have here a mix node and we have an alpha over node. So these are the most important nodes which we normally do. And what the alpha over does is we mix layers with alphas with each other. But we don't have here any mix modes. So we can't use alpha over at this point. So delete that. And we have to use the mix node because here we have all these different mathematical operations. And a thing which you have now to learn, and this is the same topic like in every compositor. For example, if you work in Nuke or Fusion, I tell the people all the time that they have to think a little bit what compositor means or what compositing means. It's only math. It's plus, minus, divided, and multiply. So still the same operations which you have learned, but this time about pixels and their information. And this is exactly what you can select here now. So what we want to do is we take this direct part here, for example, in the first slot. You remember this is the background. And then we take this indirect part, so the additional light which came from the other surfaces into the equation, and we put it here. And you heard my word, the additional part, and so this is maybe a helper for you to understand that a little bit better. So you have now to search for a mathematical function which adds to something. And if you take a look here, you see there are divider lines here inside of this list here, because these here, lighten, screen, color dodge, and add, are additive methods which add something. And the purest add which you can have is add. In other compers, like for example Nuke, they are named plus. So that's exactly what we do here. And if we now plus this, and we can mute now this node by M, you see we add now the light from the indirect pass to the existing light of the direct pass. And that's exactly what we need. So if you want to learn compositing, keep in mind if you have light sources and light information and you want to bring them together, it's always add. Sometimes it's add or plus, which is really plus. And sometimes it's screen. But yeah, this is a little bit more complicated topic. So let's say additive, add. So we can press the M key here, or sorry, we can press the H key to bring this here in a smaller node here. And now we talk about the diffuse color here. Now we have these colors here, and we have the lighting information. And if you look into the lighting information, you see bright areas and dark areas. And it looks a little bit like shadows, like ambient occlusion. You remember I showed you ambient occlusion before. So this here, this shading information is really how to shade with light and shadow something. And this is the second reminder. If you have to shade something in a compositor, you normally multiply the information. You take every pixel and you multiply it by the shading information. So let's go in here again, take a mix node. We take now the light information here. Now we can output that. And we go then to multiply. And you see, we have again 3 different modes, dark, multiply, and color burn. So these are multiplies. And we take the standard multiply here, and you see nothing happens, because if you multiply something with white, you see it here, and white is 1 mathematical. In every channel you have the value of 1, nothing happens. But if something is darker than 1, for example, it's half gray, so 0.5 would be a gray value, you bring down the value which you deliver here. So if you have, for example, perfect red, which is 1, 0, 0, and you multiply that by a shadow, which is, for example, 0.5, you get as a result, again red, but 0.5 in the red channel, 0, 0, so a darker red. I hope this makes sense. So every time you shade something, you multiply it. So let's take now the diffuse color and put it here. Multiplies on, and this is the result. So if I press now the M key, you now see you have all your colors here going on, and they are now shaded correctly with this shading information here. Another question which I always have in training is this order here now important? And the answer for that is no, but you can test it. If you have the node wrangler active, which you always have, and you take, for example, this node here, add, and you know it from math. So if you press Alt S for swapping these inputs here, you see no difference at all. And if you now go to this node here, Alt S, swapping these, you see absolutely the same. So the order here is not important. So I hide now these two. Wonderful. And one thing which you have now to keep in mind, and this is important, our viewer here is using an alpha. Same here like composite. You see, alpha on, alpha off. And if you now look here into the result, you see that the alpha here is vanishing. If I could take now the original image here and say use alpha yes or no, you see without the alpha we have a black background. With the alpha we see this checkerboard. If we now go here to this information here, you now see we don't have any alpha left. Also, if you now take a right mouse button here, you see the alpha here is 1 everywhere. So every pixel is now visible. And so the background is also visible. And if you go here to add and do the same thing, yeah, you see here the same. So you lose your alpha with this operation. So it's a little bit different than comping here the beauty passes. How to get rid now of this problem here? We need a node which works with alphas. So Shift A for going to the nodes, and you remember that I had defined a keyboard shortcut for this search field here. So if you now try to find it, you can go to the search field, which is Shift Control A. So Shift Control A, and then you can type alpha, and you see there are 3 nodes here. And I can show you where they live. They are here under color. There's an alpha over node, which is our combining of our stuff. And then we have a set alpha and a convert alpha. There it is. So let's talk about these two here. These are really important. If you want to bring an alpha into an image, so you want to remove the background by its alpha, then you normally take a alpha convert here and say straight to premult. And then if an image has an alpha, you remove it. And if you come from other applications, again nuke, this is premult. Yeah, you say if you have a node which is a premult node, it's the same here in Blender, it's named alpha convert in the mode straight to premult. If you unpremult, if you now say, okay, I want to have my background back, but still have an alpha stream, then you can switch it here from premult to straight. And this is important if you make color corrections, for example. There's a rule as a comper that you never make color corrections if you have a pre-melted image, because you get black edges around these areas. So that's the node we need here. But we also have here an unset alpha node, because we don't have an alpha here, which makes sense for us. Yeah, you see here, if you now make a right mouse button click to sample the colors, you see alpha is everywhere 1. So this alpha is destroyed. We can't use it anymore. So we want to have an alpha. And if you go here, we have an alpha here. That's the alpha we need. You see, here are the objects and there it's black. So this is something we want to have. And the sampling of the color doesn't change here anything, because the alpha here is now a separate image. It has not an alpha itself. So it's only the color which is important. White means 1, black means 0. And this information here, this grayscale information, we now want to use as an alpha. And we do that by set alpha. We take the image, which is this one here, without any alpha at all. And now we take an alpha which we want to use. Some people load in, for example, black and white images and say, this is my alpha, and you can use this set alpha. Or you can now take this alpha here and bring it into that here. And now you see your background is gone again. So now you see the recipe which we need. We combine the passes here, and then maybe you have to bring your alpha back so that you have now the same result like here. Yeah. And now you say, okay, understood. But what about these reflections which we see here? Same thing here. We have the glossy direct, we have the glossy indirect, and the glossy color. Now we can work this through here again. So let's take our quick favorites again, and we take our mix. We say we want to have direct, we want to have indirect. We want to add them together. Okay, these are our reflections now. Shading information. Then we take another one, mix, and say we want to have the color. We want to have the shading information here. And then we want to have them multiplied. And that's it. So these are the reflections before and after. You don't see many differences here, but that's exactly what we need. And now we need a little bit more space. And what we now want is we want to have this information here and this information, and we want to combine these two. You see that I've moved the set alpha a little bit to the side, because maybe it's absolutely enough we do that here before the last step. So I bring these here to the side and say, okay, this is then the final thing, so that we don't forget that. So we want to combine these two. So let's take a mix node again. And now we say, okay, we have the diffuse amount, which looks like this. We have the glossy amount, which looks like this. And now, what's the mix node? Look at that. We have that here and that here. And these pixels are black, which means 0. The brightest pixel, where we have reflection, are brighter than 0. So this is a typical thing where we add light again. So we bring light sources together. And this is add. And now you see this is the result now here. Great. And then you can tell the system, okay, set the alpha again, so we get rid of all this clutter here. I hope this makes sense for you. And if you have now another pass, for example, here we have transmission or so, it's the same recipe, all like this here. But if you forget this in the Blender documentation, which you can get here directly here under manual, there's the recipe also explained, so you can use it from there. Okay, now we've brought all these passes together, and hopefully this image looks like the original one. Now comes the question, why do you want to do this job if the image at the end looks the same? Because now you have more control about these steps here. One example, what I want to do is I want to recolor one of these guys here. For example, the back guy here. If you want to change the color, we first have to separate this guy. So this is something we do, for example, with the Cryptomatte. I explained the Cryptomatte in the last tutorial, but we use it in a moment. But if you only want to change the color, but not the reflections which are going on here, you can't do that in this beauty here. The reason for this is really simple. If you now make a color correction, let's take one. Let's go here into the colors, and what do we do? Let's take a color balance here, a big one, yeah? And we say, yeah, take here these guys, they look like this. And if you now change them here, for example, make something reddish here, you see, you have to look here, or let's get rid of that for a moment. You see, we really change everything, not only the colors of these objects, but also the colors here of the reflections. And that's exactly what we don't want. We only want to change the colors of the objects. So let's do that now. And that's the big advantage now of our setup. First, we have to find the right color information. Where was the color? We go here to diffuse, because here was the color. So if we go here, you will see this is only the color of the objects. And now you can target this here. Or you can even go deeper here and say, yeah, but the color itself was the diffuse color here. Remember, this is the diffuse color, and then we multiplied the shading information onto it. I don't want to change the shading information at all. I only want to change the diffuse color here. So what you can do now is can take, for example, this color correction here and go here into this stream. And now you have to make a little bit space here for yourself. Normally, I have a little bit more screen space here, but while capturing this is a little bit small, but yeah. And now you see, you change only the colors here of these guys. I make this smaller. And if you now multiply this here with the shading information and then you add the whole thing, you see you don't change here the reflections. That's the whole idea behind that. And what we now have to do is we don't want that this color balance here works everywhere. So how to do that now? Really simple. You see that we have in most correction nodes where it makes sense a factor. And if you now bring the factor down, you see you tell the system how much you want to bring into the system. And this here is a typical input where we can use a mask. And we talked about masks and matte creation in one of my last tutorials. So let's do that now. I go now here and I say I want to have a Cryptomatte. And we take the information. We want to work on object level. So let's take the 3 object outputs here. We also need the image here so that we can see something. Then we go into the pick mode. We now say we want to pick this background object here. That's it. And then we only are interested in the matte here. So if we now make this small and take now this factor here, bring it into the matte. And if you now go to the color correction, you now see, I press the M key. We are only correcting now the back guy here. Yeah, so that's exactly what we want. H key again. Then we go here to our add. And if I now go back here to the color balance, you see reflections are still the same like before, but we only changed here the color. So I hope this helps you to understand the recipe a little bit more. And yeah, in the next step, we want to talk a little bit about different ideas, what we can do and what you maybe have done in other node-based compositors. So we want to do now the same things here. So let's make a little bit order here. What I do in big trees here is I encapsulate stuff. So what you can do here, for example, is that you select all these nodes here. For example, here this output here after the set alpha is everything what we do to rebuild the beauty. What you now can do is you can select all these nodes here and make a frame. So you can go here and say join in a new frame or Control J. Then you get a frame here. You can select this frame here. And if you then go to the item options, you can name this. For example, this is the beauty. so that you know that, and then you can change also the color so that you later know what's going on, and also you can change here the label size so that's a little bit bigger. Yeah, and hopefully this helps you then later to understand your script a little bit better. And we only want to work then from this point here, but if you have something to do, you can dive into that here and work inside of that here again. Okay, that's it. Let's switch here to these guys here. And this is the ramp and the floor. And like I've said, I want to now tell you a little bit how the data passes inside of Blender work. The data passes are these passes here. We have here Z, which is the distance from the camera to the object in the scene. We have the mist pass. We talked about the mist pass before. It's normalized, so it's always between 0 and 1, and is also something which has to do with the distance, so how deep the scene is. The normals are the object normals. Vector is motion vector if an object is moving, and UV are the UV coordinates, which you know from modeling. These are exactly the UVs. Let's take a look into them here. So this is depth. You see everything seems to be white, but if you use your right mouse button here, you see in the areas where the floor is and here the ramp is, there we have values, and these values are extremely big. That's the reason why everything is white here, because here we have a red value, for example, of 23, which means 23 brighter than white. The reason for these really bright values is that this is really the distance from the camera to this point. So the depth is always really big, because if you have a scene which is more than 1 meter in depth, you always get these crazy values. To press everything in a normalized way, you can use a normalized node for that. So if you type normalize, you get this normalized node. And if you now bring this here in and test this, now you can see this thing. The normalized node takes the full histogram which you deliver, takes the lowest value, the highest value, and press everything between 0 and 1. And now you can see what I have explained to you. And if you now take a closer look in the depth paths, you see it's really the depth, but you see these jagged edges here. And this is really important information. Data passes are normally not anti-aliased. And this is good like it is. It's important because anti-aliasing means mixing values between neighbors. And if you, for example, want to have a vector or whatever, it doesn't make sense to mix this with the neighbor, because you only want the information where this pixel lives. And so Z-pass is no exception for that. It's important to know exactly this pixel is exactly this amount from the camera. And it doesn't make sense to mix this with an infinite background, because then you get an information which is not correct anymore. But sometimes this makes a problem. For example, if you have a moving object and you have rendered motion blur into your image, then you get half pixels. And then this can be a problem in compositing. And for this, Blender has a mist pass. Let's take a look into the mist pass. If you take a look into the mist pass, you see it's different from the brightness, because the mist pass is always normalized automatically. So you don't need the normalized node for that. So get rid of that. But it's also anti-aliased. So you get a better quality. And it depends what you want to do, if you want to use the mist pass or the Z pass. So you have both. But before you can use the mist pass, you have to configure it. And this is really important. It's scene depending. So if you go here to the world settings here, world properties, you see here there's the mist pass settings. And here you see that our mist pass starts with 5 meters behind the camera and ends with 29 meters. And I explained in the last tutorial how you find these values, so I don't explain this again. But yeah, now we have a good mist pass here. And what you now can do with this mist pass is, for example, compositing tricks. What I do sometimes with the mist pass, for example, is if you want to give a scene a little bit more depth, a little bit more feeling of depth, you have to keep in mind that if you look into the world which is far away is a little bit more bluish because of the skylight, and the saturation goes down. And you maybe get haze in the distance of fog. And so this is a really good idea how to make a volumetric scene. You can render volumetrics in cycles, but this here is much cheaper because it's in the post. So we use the mist pass for making fog or mist. That's the name for that. So let's do that really quickly here. What I do is I go into my nodes and I take a mix node. And what I do is I take now my image. Here it is. And I take the mist pass. And what we want to do with the mist pass is we want to bring it here over the whole thing. And because the mist is brighter, we add it. So again, add. And now you see what happens. Yeah, if you now look here, you suddenly see, okay, it looks a little bit like mist, and you see it better if I deactivate really fast the alpha here. Yeah, you see it looks really like mist. The problem now is that you don't have control at the moment at this point. So let's talk a little bit more about control here. So what you now can do is, for example, you can tell, okay, I want to change the color and how this mist works. So how fast it changes. And for this, I normally use a color ramp. So if you go to colors, you find here a color ramp, or under converters, sorry. Yeah, because it converts values. We talk about that. And we take our mist, bring it in here as a factor. And what now happens is, you remember mist is normalized between 0 and 1. You map these values between 0 and 1 to these values here between 0 and 1. So, and this is the thing you output then. So let's first test this here. It looks the same because black comes in and goes out as black. White comes in, so 1, and it goes out as white. But what you now can do is you can start playing. For example, you go here and say, I take this here and bring it nearer here. And you say, yeah, this is London, yeah. And you can bring it back. Or what you also can do is, if you have selected a point like this, you see they are numbered. This is 0.0, this is 0.1. You can change the position also here or here in a bigger layout. What you also can do is you can click here now into this color field and you say, yeah, we don't want to have it white at the end. We want to have it a little bit bluish, so less saturation. Yeah, we don't change here the value for this point, but maybe I want to change the value here and say, yeah, in the foreground, I don't want to have nothing, maybe a little bit, so that we fill also here the mist. It depends on you. Yeah, you can play with these values. You also can set new points with the plus here, and then you can change this point again. And this is now the mist we use here for our overlay. Now you see how much control you have. And if you then say, okay, I have the style, how fast it goes, and so on. But now I want to change how much mist we have. We have still the factor here, which we can use. So you can add a little bit for the atmosphere, if you like. So that's an idea how to work with the mist pass. Remember, if you have now 3 images here, or 3 layers, you have to combine the mist passes first. So for these are mathematical functions like minimum and maximum, for example. But this is maybe a topic for another tutorial. So let's leave the mist pass. And I throw this away to have a little bit more space here. And the next thing I want to demonstrate for this, we maybe take here these guys again here, is I want to show you a really cheap way of relighting scenario. We have 2 light sources here, the top light and the warm light from the right, but maybe you want to change this. And what we have as an information here is the normals of the object. So if you take here a look into the normals, you see now that the top of these objects is blue. Because in Blender, the Z-axis is looking upwards and Z is blue. Green is the Y-axis and red is the X-axis. So you exactly see in which direction the surface of these objects are looking. What you now can do is you can now use this information. And for this, we have a node which is named a normal node. So take a normal node and you see these 2 balls. One ball here is an input. So we take this input and we grab now the normals from our guys here, which looks now like this here. You see, it doesn't look good. Yeah, because this is vector data, doesn't make sense here for Blender. But if you go to dot, which means the dot product, you get something like this. What is the dot product? With the dot product here, you can separate what you want to see. It's a vector which is perpendicular on a surface, and you can separate. And for this, you need to make a vector so that you get this separation. And the vector is generated in Blender with this ball here. So you see, it highlights if you go over it. And if you now click here and move this ball around, you change now the vector. And you see that you get, through the dot product, different areas of our surface. But these shadows are always on the surface. So you can use them for shadows. But what I want to do now is I want to use this here as a mask. So let's go in here to the colors. One example would be, what do we do? Let's go again to color balance. Yeah. And I now want to bring a little bit warmish color to these objects, but I want to say where. So let's this time take here at the end, and this is color correction. So let's take this one here. Looks like this, original ones. And now we take our factor here, which is the dot product, which you are after, and bring it to the factor. And now you can make first a really heavy change. I bring it here to this pink. And now you see that you have these pink colors here from the downside. And now you can go back to your node here and change now the vector. And now you see where you place this color here. And if you see here these artifacts, keep in mind that this is low resolution, and also if you go here to the options, you maybe are not in the highest quality, and yeah, so it depends really what you do here. But the idea here is normally that you don't overdo it like this, but what we want to do is I want to bring it a little bit here into the warmish area, and then I can relight now here my objects with this idea. Or what you can do is directly, this is a mask, so you can work with a mask like that. So I hope this helps you to understand a little bit more these manipulations for relighting ideas here of these objects, because you have the normals here inside of Blender and cycles. Let's get rid of these here. And the next thing, it's also a little bit of manipulation, but yeah, maybe useful for your work. You have this floor here and you want to add a little bit more life to the floor. And for this, I want to add a texture to the floor. Okay, let's load a texture. We go here into the input nodes, and here we can say I want to load in image and load here something. Let's go here to some assets. Let's take a look. Okay, don't look like useful assets. Text images. Here we are. Here we have a nice texture. And it looks like this here. What you now want to do is we want that this texture here is projected to the floor. But we only have a 2D information, yeah, because this is rendered. And we don't want to re-render. And for this, we can use the UVs here. UV coordinates are made while you are modeling. You remember, if you go here to the layout, select this guy here, go to UVs, you see these are the UVs of this guy. And if you then go here to this floor, you see there are also UVs here. And what we now do is we use these UVs. They look like this here. Encoded here in every pixel is the position here in 2D space. And then we need here now a distortion, which is going on. And there's a node for that, which is named UV map or map UV. And what you do here is you take an image, which is our floor here, and it's distorted by this vector here. And this vector is now the UV here. And now you see this is the result. It's not our rendering. It's only that our image is now distorted by this UV coordinates, and it looks like this here. And what we now do is we now want to combine this here now with anything here. So let's do a mix, for example. Take the original image and we take this new image here. It looks like this. It's now over it. Now you can see with the factor, yeah, we are really over our objects here. And what we now want to do is I want to separate with a factor again what we want to have. So let's go here and say we need our friend Cryptomatte again. You also can use ID masks, but this here is much cooler and faster. So we go here to object again. You also can address materials if this helps. But in our case, say we want to have the floor here. This is the mat for it. Great. H key. And then we say here in the mix where we bring now this texture on that we want to use this gray output here. Hopefully I found it. And then we go here and say, let's take overlay, for example. Let's test what's going on. Ah, I'm in the pick. You see, sometimes closing everything is not the best idea. Okay, that's it. Yeah, and now you see, overlay does the job. Now we have a new texture here on the floor. Little background information. After you've learned that here, and you say, okay, this image here should only be the color information which you want to add to an object, you can do exactly that. So this is only the demonstration on the full beauty pass, but you also can do this in separate light passes like we've talked about. So this is for retexturing purposes. And the last thing I want to talk with you about, and then I think you have seen a lot here, is how to blur stuff. Blurring is always important, and the first blur you always want to have is defocusing. Okay, let's take a defocus node here, and let's take a look into the defocus. You need an image which you want to defocus. Let's take these guys here again, and you see nothing happens because now you have to make some settings, and these are sometimes a little bit confusing. You see that there's a Z input here, so you can add your own information how you want to defocus, and this here is then between 0 and 1. So if you then change that here, you can manipulate that, but this is something I normally don't want. What I want is I want to use the real depth I have in an image. So what I do is I say use Z buffer, and then I connect this to the depth of my image, because that's exactly what I want. And then I go into my node, and what I want to do is I have here an f-stop, and this f-stop is ridiculous high, 128. Let's do something ridiculous low, 0.5. And now you see, ooh, we have here suddenly blurred information. You can deactivate preview here, but then the node takes much longer, so this is something which you normally do for the final render. We want to work fast at the moment. So let's talk about the information. Z-depth comes in, and it uses this information for simulating your camera. So the wider the aperture is, the lower the f-stop number is. Now that's the reason why I used 0.5. So if you have, for example, something more realistic, let's take an f-stop of 2.8, for example, then you see you get a little bit of blurring here, depending on the depth of your scene, but I want to overdo it so that you really can see what's happening now. Now comes the interesting part. You use, inside of Blender, this depth pass. You remember this white one. And the really ridiculous cool part is you can now change it after rendering. Let's test this. If you now go into your 3D scene, now we need our window back. Here it is. Yeah. You remember when you select the camera that in the camera settings, let's click that so that we get here our camera settings. We can activate under viewport display the limits here. This is this yellow line, and we talked in one of my last tutorials about this focal point here. And what you can do here is this focal point is stored here under depth of field, 16 meters here. And now look what happens. If you now grab this focal point, and I found that sometimes this is a little bit hard if you have the compositor running at the same time. So it works, funny enough, if I go here and do it here, but not if I have the window here. But yeah. What I do so that I can show it at the same time is I go here to the distance, and you can move it here. You don't need to activate depth of field. It's not important, but you can move it here. what I do now is I bring this point here really close to the camera, so start at the floor here, you see? And now, if you go back here and you trigger a re-render, and you do it, for example, by pressing the M key, mute, and then bring it back, you suddenly see that everything now is blurred. Because now Blender has reinterpreted your camera information here with this node. So you have still a live connection here. And that's so cool. So if you now go here again and say, not the viewport display, but here the distance, I want to focus, for example, now here at the back of my scene. M key for triggering. You see now here is the focal point. That's the thing. Last thing now is how to combine this, because you have Z now here in every of these. What you normally do is that you can now have more than one defocus node here. And the setup is done. So what you can do now here, for example, is if you have now these guys here, you can bring it in here. I'm not sure in front of or after that, but yeah, it's not so important. I think you understand the concept, and then you can test how it looks. I also connect these guys here, and now you see you get the same fitting result like this here, you see? And now you can work here in this area, move your widget around, and then you defocus every plane. And the cool thing is, sometimes from artistic reasons, you go in here and say, yeah, the most important objects here, use a little bit of a different f-stop, only to change a little bit the appearance. So this is possible to do. And what you also can do is you can change here the aperture so that it looks a little bit more realistic. And I found that gamma correction here looks better because you get a bloom effect, which is really nice here. You see, it looks better. And don't forget later to deactivate preview to get the nice result at the end. So this is defocus inside of this system. Then we have another blur node, which is a really good one, which is Bokeh Blur or Bokeh Blur. And let's take this one, and this time we take these guys here. So I first go here, take these, and you see it directly blurs. Really strong here at the moment. It's nice because you have here a size which you can change. So 1 is okay for me. And what you now can do is you have here a max blur. This is important because blurring takes much time and maybe it's too long, and this max is absolutely okay. But what you can now do is, if you ever watched images from photographers in night photography, you see that the bokehs, so these really bright pixels here, are not round, and they are normally in the shape of your aperture. And for this, we have here an input. We can add our own bokeh image here. And if you really want to have an aperture for this, you can go here to input, and you can generate one, a bokeh image here. So this here is an editor where you can have these different forms. You can change rounding, the angle, the lens shift, and you can use that here. And then you see that these bokehs here get this form, and it looks much, much more realistic and better. Another thing what you can do here is that you have here a variable size, which is a really interesting idea here, because normally it takes this size here. But if you say variable size, you can add your own texture where you have bigger and lower values for the bokeh. Sounds complicated. Let's demonstrate this really fast. And for this, I want to show you this time a texture. So we never talked about these textures. So images we had, but not textures. So make a texture here. And what a texture is inside of Blender is, that's a connection to the texture editor, which is in Blender here. And in this texture editor, I've generated a texture with the name myTexture. I selected here as a texture type. You see there are different types. I used the blend here, and inside of the blend, I opened this up and made a color ramp, which looked like this here with a black stripe in the middle. And this texture is named myTexture, and I can address it here directly. So it's loaded in here. And what you now can do is you take now this color information and you convert it to the size here. And if I hooked up everything correct now here, you can start changing now here where this black stripe, for example, sits. And maybe this would be better to have that here first in a bigger image, something like that here. And let's test this again. Yep. Sorry that you have to wait. So maybe you zip at your coffee. And maybe it doesn't like the color. It has to have the value. Let's test this. And let's make it easier. Make it first like this. Bring it into the middle. Then we test this again. I have forgotten the variable size. Thanks for helping me, guys. So take this and bring the color back in here. And then we try the whole thing again. Yeah. And now you see something really interesting going on. You see here on the left side, we have a blurred area. On the right side here, everything is sharp and then it gets blurred again. The reason for this is really simple. That black means 0. And if you have now this black area, now we can switch it again here. That you now say exactly where you want to have these areas where you want to have sharpness. You see, it's really a little bit of testing so that it really fits exactly and how you interpolate that. But it's a really interesting effect here. And in other compositors, it's named Vari-Blur. Maybe you heard that. And so this is now possible through a system like this here. You see here it's blurry, here it's sharp, here it's blurry again. And everything can be done with these controllers here. So this was that. The last thing, or last two things here, which I want to show, and then we have to close this session here, is the glare. So for that, we had here our own image where we had our emissive part separate. So we also activated the emissive layer here for this. So if you go here to emissive light, to the render layer, we had here our emission. This is emit here. And if you now want, you can have a glare effect. And because it's this time on its own layer, we don't run into problems. So we can have a fog glow, for example, make this not so big, maybe only 6 here. And this is light. So if you want to comp that back here to the whole system, you go here and mix it in with an additive mode. So add, for example, now you see it looks like that here. And now you see, now this fits really well. Don't forget also to work with the alphas here, but yeah, this is how to work then with a separate layer and a glare. And if we now want to end with our camera effects, I found it interesting to show you the lens distortion at the end. So lens distortion makes an image at the end a little bit more realistic, because every lens we have has distortion. And yeah, so what you can do now here, if you now take, for example, something like that here, you have in this lens distortion here distortion value. So make it not too strong, but you see directly, if I bring it down, you see you now start to shape this image here in one or the other direction. And like I've said, you have to be really careful with this. Well, you don't overdo it. I make only a little bit. But what's also really, really interesting is, and this is something also really good for realism, is the effect of chromatic aberration. So normally you see at the edges, if something is blurred, that you have a little bit of a dispersion. It's named chromatic aberration, and this lens is, or this lens distortion node is able to do that. So if you do something like that here, it looks like a really cheap lens, because you get here these fringes at the side. So also don't overdo that. But yeah, this node is really selling the point that there was a lens involved. I think that was long enough. We have played a lot with these compositing nodes, and I hope I told you a little bit more about how this system works. If you are now hooked with the system, please send me your images and tell me a little bit about your experience. If you have questions, please comment under the videos. If you like these videos, please subscribe, give me a thumbs up. You can support me on Patreon if you like. And now we close this compositor sessions, and in the next Blender for production I was thinking about making something with 2D and 3D tracking, so give me a comment if you like something like that. I will now make some Houdini tutorials again, and then we go back into Blender to make these tracking videos if you like that. So have a good time, have fun in Blender. My name is Helge from pixeltrain. See you next time.